Okay, let's go ahead and take a further look at the modulus and the argument of complex numbers. Now let's go ahead and just take a look at two complex numbers here, z sub 1 and z sub 2. Now, what we're going to find out is that not all complex numbers have a modulus of 1. And so I'm going to go ahead and substitute that fact, or use that fact, to call z sub 1 r sub 1 cis of theta sub 1. And z sub 2 is going to be r sub 2 cis theta sub 2. So when we go ahead and analyze the modulus and argument for each one of these complex numbers which are written in polar form respectively, then the modulus of z sub 1 is simply going to be r sub 1, and the argument of z sub 1 is simply going to be theta sub 1. And the same thing for z sub 2. So now what we want to do is we just want to go ahead and take a look at what is going to be the modulus as well as the argument when we multiply and divide complex numbers in their polar forms. So notice that what happens then is that if we take a look at z sub 1, z sub 2, which is this and therefore this, we can then go ahead and say that the modulus of the product of these two complex numbers is simply going to be equal to r sub 1 times it by r sub 2, and the argument of z sub 1 times by z sub 2 is simply going to be the sum of the two angles of the original two complex numbers. When we go ahead and take a look at the quotient is going to be very similar in the sense that the modulus of z sub 1 divided by z sub 2 is just going to be r sub 1 divided by r sub 2, and the argument is going to be theta sub 1 minus theta sub 2. We're going to take a look at something here that's a little bit different in number 3. It's saying, what if we go ahead and take z sub 1 and raise it to the n power? Now, if that's the case, then we have r sub 1 cis theta sub 1 raised to the n power. And again, what the powers represent is just repeated multiplication. And therefore, let's go ahead and just write it this way and say that we have n factors of z sub 1. Therefore, we have r sub 1 times it to itself n times, and therefore r sub 1 n, and then cis of n times theta sub 1, because our rules of multiplication says that we just need to go ahead and add all of the thetas together, and as there are n factors, we have n theta sub 1. So therefore, if we go ahead and take a look at the modulus of z sub 1 raised to the n, well, that's simply just going to be r sub 1 raised to the n, and if we wanted to refer back to the original modulus of z sub 1, which of course was r sub 1, then we can rewrite this as just the modulus of z sub 1 raised to the n power. With regards to the argument of z sub 1 raised to the n power, again, it's just going to be n times it by theta sub 1, and therefore theta sub 1 we knew was going to be equal to the argument of z sub 1, so we can just simply go ahead and write that as n times it by the argument of z sub 1. So if we go ahead and take a look at the argument properties in particular, which is this one, and this property, I'm hoping that what you can see is that these argument properties are the same as the logarithm laws. Now this one looks very similar to the logarithm law here. Let's get this one to look a little bit more similar to that logarithm law as well. This is just going to be equal to the argument of z sub 1 plus the argument of z sub 2. So I think now that looks a little bit more like the logarithm law that we know. And this one here is going to be equal to the argument of z sub 1 minus the argument of z sub 2. Okay, so now this one as well looks much more like the logarithm laws that we know and are so familiar with. So there you go. If we go ahead and take a look at the modulus and arguments of complex numbers when we perform multiplication or division on those numbers in their polar forms, we have some very nice properties which are very similar to the logarithm laws when we discuss the argument. Okay, and that's it. And we'll go ahead and take a look at some of the problems that we have in the book, and we'll take care of those questions in class the next time that we meet. So we'll see you next time. Bye.